Claiming that the Earth is flat is a fail all on its own. So in order to find the biggest flat Earth fails that I could in the flat Earth movement, I had to go to one of the dumbest, one of the most arrogant people, to see how low they could sink. Now, all of these flat Earth fails are not necessarily about the flat Earth, but the kind of thinking that is required in order to accept such a claim, and the kind of stupid shit that you have to tell yourself in order to keep believing that the Earth is flat. So I present to you Jeranism's top 5 flat Earth fails.
Now, back to our passenger jet. Now, you said things from the northern hemisphere had a tend to pull right. Now, do you mean the forward momentum will stay? Does it go to the east, or does it go right?
They said to the right. They didn't say to the east, they said to the right. And you know how I know that? Because I paid attention, and this is what they said.
So if you threw your paper airplane in a straight line toward the north, it would land somewhere to the right of Nebraska. Maybe in Delaware.
Let me tell you your problem here. Let's change our throwing location to the bottom of the southern hemisphere. Now, does this phenomenon cause the paper airplane to go east, which would be the blue line? Or does it cause it to go left, which would be the red line? Or is it only as you say, and I should mind my own business?
Now, stay with me here, Jeranism. They said to the left. And you know how I know that? Because they said it in this part of the video that you showed.
An object traveling from the equator to the south would get deflected to the left.
Because hopefully everyone sees the problem here. If we change to the bottom and it goes east, isn't this the same as the northern hemisphere? And if we're on the bottom and it goes left, well, then it's the complete opposite of what you just described. Starting to sniff doublespeak.
How can you say that the red line is the complete opposite of what they said when they said that it turns left? That is exactly what they said.
So again, just to make it clear, if we were in the northern hemisphere and we went north, and instead we were looking south, and we threw our paper airplane again, would it go east, as in towards Delaware? Or would it go right, as in towards California? Please explain yourselves a little bit better, because if it goes to the east, then that is the same that you just drew in the southern hemisphere. You're lying, and it's pathetic.
You are trying so hard to make this video come out as a lie. But what is happening is that instead I am noticing that you are incapable of paying attention. In this part of the video, they show you what happens when you have air moving in the northern hemisphere. And if you notice the top arrow, it's the same as your example of something being north and moving south in the northern hemisphere. And look at what they drew. They drew an arrow pointing to the right. And here they showed the same thing, but for the southern hemisphere. And once again, look at the bottom arrow. It's pointing from south to north. And once again, it is moving to its left. And you know what the best part is? That you showed this in part of your video. You saw this. You have no excuse for not understanding this. You are trying way too hard to make this video come out as being full of lies, only to show that you have the attention span of a goldfish, and that you are incapable of understanding simple drawings that are presented clearly to you.
So it should be painfully obvious that somebody has a significant size issue, and that somebody is NASA. You'll see here them bringing the Saturn V in You see the crowd that's gathered to watch. In the next picture, we have another crowd gathered to watch something else be wheeled in. And in the next picture, you put them on top of each other, and you can see by the red lines, it's the same people. So, interesting, and those both came from NASA's website.
The first time I heard you say this, I actually wanted to give you a little bit of credit because I thought it was rather clever of you to have spotted this. Then I realized that you probably didn't spot it yourself, but you probably got it off some Flat Earth meme or some Flat Earth forum and you just regurgitating without thinking about it. Because it took me only a few seconds to Google the image and find out that the images, that one is a real image, the one with Saturn V, and that the other one is an artist's rendition. And it's not like the second one is actually portrayed to be a real picture. Every time I saw that picture on a NASA website, it said it was an artist's rendition.
So I got to the channel and saw something that I don't normally see. And that is the sun, not behind the Earth, but up above it there. And as we watch, we will notice a issue. Also, you see that little spinning satellite dish thing is so funny. Like that does anything. Oh boy. But if you notice what I notice here, the sun is running away. So I don't get it. I thought that the sun didn't move. Anybody? Anybody? Bueller? Does the sun move?
Or, stay with me here, journalism. The sun isn't moving, but the camera is moving. Now, how might I know this? Now, it is kind of difficult to tell because there aren't a whole lot of landmarks for me to see how things are moving. But since I already know that the sun doesn't move, that might be a good place to start. The other place that you could maybe tell that it's the camera that's moving is right here. Do you see this part of the Earth that is moving? Now, unless this is a time lapse, if this is just a regular feed going at whatever 60 frames a second or 24 frames a second or whatever the hell, this is moving far too fast for it to just be the rotation of the Earth. Now I'm guessing that this is what you think the Earth looks like when it's rotating in space. Well, I shouldn't say I'm guessing. I know this is what you think.
This is the Japanese orbiter that is orbiting the moon. This is a video they've shown that is their proof of the Earth. And you'll see, as you look at that the clouds are not moving, that the Earth is not spinning.
Let me explain to you why you're so wrong about the Earth needing to rotate in video. Right here, from the east edge of Africa to the west edge of Africa on the equator while traveling at 1,000 miles an hour, this whole movement takes about 2 hours and 20 minutes. Let's go back and take a look at the live footage that you provided. Here you'll notice that the Earth is moving incredibly fast. Remember how I showed you earlier that it doesn't actually move that fast? By noticing that, we can now tell that it is not the Earth that is rotating, which means that the thing that must be moving is the camera, and that we are moving forward. With all of this combined, now you have yourself a great explanation as to why the sun is moving, as you so eloquently put it. You know what the best part about this is? Is that you rightfully claim that you're not very smart, but then you also claim to think for yourself, to critically think, and yet you never bother to look into this video clip more than just saying, oh, the sun is moving, and then you stop thinking right there. You need to stop saying that you think, because all you do is you take the first feeling or the first impression that you get from something and you go with it. You have absolutely no critical thinking skills.
What if you gone out on a limb and said something that's controversial? You just believe whatever you're told and walk around with your chest puffed out, acting like you're cool, commenting on my videos. Oh, you don't believe in gravity. Ha 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 ha. No, I don't believe that people are upside down on the bottom of a sphere because it's impossible.
I'm sorry, could you repeat that?
No, I don't believe that people are upside down on the bottom of a sphere because it's impossible.
All right, I just want to make sure I understand this. You don't believe that there's people on, say, Africa and then people, say, over in Australia because one would have to be upside down and that's impossible. Am I getting that right?
Now, the first little scientific proof I want to get into here is the fact that the moon actually is inverted depending on which hemisphere of the Earth you're on. So if you're in the southern hemisphere as compared to the northern hemisphere, the moon is going to appear differently because you're looking at it from two different angles. You understand what I'm saying? Because the Earth is indeed a globe.
Oh, I understand what you're saying. Because the Earth is indeed a globe. The fact that it's a globe. I get it. See, I always get confused. I always think there's other way to look at things. Like you could just pop the flat Earth model in there, put two people on the Earth, and realize that both of them, if they're facing each other, were looking at the moon. The top for one would be the bottom for the other. I don't know.
I'm sorry, Jeranism. Didn't you just say...
No, I don't believe that people are upside down on the bottom of a sphere because it's impossible.
So it's okay for people to be upside down as long as it's on a flat Earth map. But God forbid it's on a globe. Oh, no, 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 no. Then it's fucking impossible, right?
So here you have a picture of the moon. And you can see, if you look at it closely, that it has no hotspot, as would be required, and I'll show you here in a second. If you're learning to draw, or if you looked up how to draw a sphere, and look at the shadowing that would be required of it, that the moon does not show that at all. Notice here, I have two different balls, and I'm both showing you what the shadowing should look like. If you look at the left side, the letter A showing you that the top and bottom, letter C, of that ball on the left are darker because they would be harder to see. You would see the center easier than you would see the top and the bottom, therefore they'd be darker. You'll also see that the letter B is showing you in what direction the light is coming from. Now if we look at the ball on the right side, same thing. A and C are darker and shadowed. B tells you exactly where the source of the light is with the hot spot. And then D showing you the darker middle. Here's another picture of the moon where we see there is no such shadows on our moon. It is completely lit in total, in completeness. There is no darker top, there is no darker bottom. There is no hot spot showing where the source of the light is. So to me it does not even show at all that it is a sphere. A sphere would show significant changes in the top and bottom.
First of all, if you are going to compare the shadowing of the moon to the shadowing of your spheres here, how about you compare apples to apples? Let's compare it to when the shadow of the Earth is more like this, more when you can actually see the shadow, instead of comparing it to a full fucking moon. Of course, you're not going to see a darker area or a lighter area if you're looking at the bright part of it dead on. Second, now I have taken the liberty of making a few little renders of different spheres, and here are 3 different ones for you. Now, the reason that I did this is to demonstrate to you how there is more than one way to shade a sphere. Now, all of these were made with different intensities of light, giving you more or less shadow. And that hot spot that you found on the spheres, well, that can easily be turned on and off with a simple button press on Blender. Now, if you actually go on Blender, a 3D modeling program, and you model a sphere with the light source being that of the sun, you get this kind of image, which, coincidentally enough, Hey, it matches the moon. Would you look at that? It's almost as if there's more than one way to shade a sphere. You are being so incredibly dishonest here by not comparing objects that are similar to each other and by having this, I don't know, this ultimate way of having spheres be shadowed, this one and only way, when I can easily demonstrate to you that there are multiple ways of doing it. Let's take a moment now to look at the moon. And let's look at it very, very closely. If you look at the center of a full moon, you'll notice that all the craters appear to be pretty much just circles. As you slowly move to the edge of the moon, you start noticing that they start becoming more and more oval-shaped. And finally, if you look at the very edge of the moon, you will notice that almost all of them take a very oval shape. It's almost as if the craters are on a sphere, isn't it? Now, if that isn't enough to demonstrate that the moon is a sphere, let's take a look at the shadows that these craters have. Once again, if we start at the center, there's no shadows because the sunlight is hitting it dead on, almost as if it's a noon at the moon, and there is no shadow. As you start moving down towards the edge of the moon, you start getting deeper and deeper shadows, till once you get to the very edge, you have very striking, very dark shadows in the craters, almost as if the sunlight is hitting it at an angle, creating a shadow. These are two ways that you can go look at the moon to see that it is a sphere. You don't even need a very fancy photo to do this. You can do this with a telescope. But knowing you, Jeranism, knowing your laziness, knowing your arrogance, you are just going to say, nope, I am right, and I refuse to try to demonstrate why I'm right.